Hello there. Are you preparing to write the Jamb exam and is physics part of your course combination for the coming exams? Well, I have good news for you. This is Jamb Physics in 40 days, a series that is brought to you by Oya Learn, where we believe that by dedicating within 30 to 45 minutes of your time daily, you'll be well on your way to get all the necessary tools you need to ace Jamb Physics. Now, I know that Jamb Physics can seem a little bit tough for many students, and what we'll be doing in this series is that we'll be breaking down each of the topics into bite size for you so that it can be easy for you to assimilate these topics. So we'll be looking at each of the topics that is in the Jamb syllabus, which is about 39 topics. You find the topics displayed on your screen. We're going to look at each of these topics one after the other, and then on the final day, we'll be taking our own test where we look at least a question from each of the topics. Now, if you're ready, please do well to tell others about this, and then let's get ready to break down Jamb Physics and be on our way to ace it. Now, as I mentioned that there are 39 topics in the Jamb syllabus for physics, one of them is measurements and units, and this is what we'll be looking at first. Now, under measurements and units, these are the topics that you're expected to cover. So I'll do well to explain them in little bit. So we are having like a crash course here before we then go on to solve past questions on this topic. Now, the first thing we're looking at here is length, area, and volume. Now, we are not looking at this from the mathematical aspect, but from the physics aspect. Remember that in physics, it is measurements of things that have to do with matter and how it relates with energy, right? So what we are looking at here are measuring instruments that are used to measure distances such as length, that are used to find other things such as area and volume. Like for example, if you want to measure the length of a table, what instruments would you use? If you want to find the area of your table, what would you use, and things like that. That is what topic one, the first topic here, is about. Now, the second one is talking about mass, and mass has to do with the amount of stuff that makes up a particular material. Now, mass is one of those very fundamental quantities in physics, and what we'll be looking at mostly here is basically what is mass, can you define mass, does mass change, or is it a constant regardless of where you are, and then also what are the instruments used to measure mass. And I believe you know that to measure mass, you need an instrument known as the beam balance. Now, we also look at time. What is time? What does it mean? And then also, what are the instruments that we use to measure time? Now, many people think that once you're asked what is used to measure time, you should talk about the clocks or watches. But in physics, we measure time in seconds, and what we use to do that is either the stop clock or the stopwatch. So keep that. And then for D, we have fundamental physical quantities. This has to do with quantities that do not depend on order. They are totally independent, right? They are units, and the quantities themselves do not depend on anything at all. And then for the derived physical quantities, these ones are made up of a combination of two or more fundamental or derived quantities. So that is, to create what we call derived quantities, you need fundamental quantities. And then we also have what we call the dimensions. Now, the dimensions we look at mostly in physics is the dimensions of mass, dimensions of length or distance, and then dimensions of time. So using this, we'll do what we call dimensional analysis. We use that to determine the dimensions of a particular derived quantity. And you can also use this to actually find the units of unknown quantities. Then we also have limitations of experimental measurement. Things like accuracy, precision, errors, percent errors are things that we look at when we look at this topic. And then finally, position, distance, and displacement. We would establish what position is, what distance is, and what displacement is. And I hope that you know that these two are very different from each other, where distance is a scalar quantity, displacement is a vector quantity. That is, displacement puts into account the direction in which the object is traveling, whereas distance does not care about the direction it is traveling. It only cares about the magnitude of the total land area that is covered. So this is basically what we are looking at in the first topic of the syllabus, measurements and units. So having this at the back of our mind, let's then go on to solve some past questions that relates with this topic, and then I'll also share some tips on how you can solve some of those questions like that. So let's go. Now, looking at this question from the UTME 2023 exams, the question says, which of the following is not a limitation of experimental measurements? Now, when taking experimental measurements, there are a series of errors that we try to avoid. One of those errors is the systematic errors. This is an error that is based on fault from the machine that you are using to measure, such as errors such as zero error and the likes are systematic errors. Now we also have random errors, which are errors that they vary from different sources. They can come about by even small change in temperature and other things that you cannot measure, right? So those are random errors. And human errors has to do with things like parallax error, like when you misread the measurements you are taking and things like that. So of all these options here, the correct answer is instrument resolution. And this is because this means that instrument resolution really means the smallest changes that a particular instrument can detect. So it is actually telling you how precisely or how accurately a particular machine can measure a certain variable. So it is not an error, but even something of advantage. So the correct answer here is B. In this question from the UTME 2024 exams, it asks the degree of precision of a vernier caliper is. Now, if you don't know what a vernier caliper is, it's an instrument used in the physics lab to measure small distances, such as the thickness of a metal rule, the thickness of a glass slab, and so on like that. Now, the smallest measurement that you can take with this particular instrument is 0.1 millimeters. It can measure up to 0.1 millimeters. But of all the options we have here, they are all in centimeters. So meaning we have to convert this into centimeters. So to convert this into centimeter, we divide by 10. Right? And this would be millimeters times 1 centimeter. So we see here millimeter cancel millimeter, and then what we have left is 0.01 centimeter. So the correct answer here is option B. In this question, we see that we are asked, what is the least possible error encountered when taking measurements with a meter rule? Now, the meter rule is an instrument that you use to measure lengths in the laboratory, and it is graduated in millimeters and centimeters, where the highest measurement you can get is 1 meter, which is about 100 centimeters. And the smallest measurement you can get is 1 millimeter. So let's take an enlarged look, a diagram of a meter rule, for example, where we have 1, 2, 3, 4, 5, 6, 7, 8, 9, then 1 centimeter, then 1, 2, 3, 4, 5, 6, 7, 8, 9, then the next one, and so on like that. Now you will see that if we get to this point, we know that is simply 1 millimeter and on. So the smallest error you can get is when it falls between each of the millimeters. So we see that what we have there is between 0 plus 1 millimeter, divide that by 2, and what we have is 1 divided by 2 millimeter. So our answer is 0.5 millimeters. The correct option, B. In this question, it asks, which of the following is a derived unit? And then we see a list of units here. We have option A being kilogram, B being meter, C being Newton, and D being second. Now, before I go on to answer this question, let's quickly list out the fundamental quantities or the fundamental units that we have. That is those that do not depend on others. So we have the unit of mass, which is in kilogram. We have the unit of length or distance, which is in meter. We have the unit of time, which is in second. We have the unit of number of moles, which is mole. And then we have current, which is in amperes. Now, these are the common fundamental units that we have. Their quantity and then their units. Now, since we are looking for a derived unit in this case, that is one that depends on 2 or more combinations of fundamental quantities. we have to knock out all the fundamental units we have here. So this is not the answer. This is not the answer. This is also not the answer. The three of them, you see that they are amongst this list. So the correct answer here is C, Newton, which is actually made up of kilogram meter per second square. So you see it combines about three fundamental units in this case. So that's our answer, option C. Which of the following is a fundamental unit? The first option we have here is Newton, which is the unit of force. And force is a derived quantity. So Newton is also a derived unit. Now, next we have Watt. And Watt is the unit of power, which is also a derived quantity. So definitely Watt is a derived unit. Now, thirdly, we have Joule. And Joule is the unit of energy, which is also a derived quantity. So Joule will therefore be a derived unit. And then finally, we have second, the unit of time. And time is one of the common fundamental quantities that we have. So therefore, second will be a fundamental unit. So the correct option is D. Now, folks, if you're yet to subscribe to the channel, this would be a time to really do that quickly. Please do subscribe to the channel, because as you subscribe, you are helping us to be able to produce more useful content like this for you and for as many that will definitely need it. So please and please subscribe. It's only going to take a second, and you can also hit the notification bell icon so that every time we put out a new post, you will be alerted. Now, thank you in advance for doing this. Now, looking at this question, which of the following units is equivalent to kilogram meters per second? Now, what we're supposed to do is solve this by dimensional analysis and see which one of them will give us kilogram meter per second. So let's start with the first option where we have Newton per second. Newton per second can be written as Newton over second. And Newton is kilogram meter per second squared. So divide this by another second. This will give you kilogram meter per second cube. Right? So this is close to this, except that this is carrying a power of -3. So I need to find a way to reduce this to just -1. And the only way to do that is actually to multiply seconds by Newton instead. So we can just immediately skip the rest and then try Newton seconds. Now, Newton seconds is going to be, Newton itself is kilogram meter per second squared. Now multiply this by second. Now you see that this would give you kilogram meter per second. So that's our answer, option C. Now in this question, we see that we're given four statements. We have force and then Newton in bracket. So our guess here is that perhaps they're putting their unit in front of them. So force measured in Newton, torque in Newton per meter, that is incorrect. Torque is supposed to be in Newton meter. Then current in amperes, and then power in watt. Now the question itself says, which of the above are the correct SI units of the quantities indicated? Well, that solves it. Since we already know that torque is supposed to be in Newton meter, not Newton per meter, it means this unit is incorrect here. So the correct ones would be I, and IV. So that gives us option D as our answer. Which of the following is the dimension of pressure? So we have to find the dimensions of pressure in this case. Now to solve this, now we have to recall that pressure itself is force per unit area. So force over area. Now, force itself has its own dimensions, which is, now remember, force itself is measured in kilogram meter per second squared, and this is in meter squared. Now, what are the dimensions of this? So what we have here is kilogram, which is a dimension of mass. This is dimension of length. This is dimension of time, all divided by dimension of length squared. So if we solve this, what we'll be having is m, then L. Now what we have here will be 1 minus 2. Since we are dividing that, then t raised to power minus 2. And this will give us ml minus 1, t minus 2. So the correct option is option A. At what values of x, y, and z respectively would the unit of force in newtons be dimensionally equivalent to m power of x, l power of y, and t power of z? So basically what we have to do here is to use dimensional analysis to find the dimension of force. And then we equate it to this and then find the value of x, y, and z. Solution. Now, force is measured in newtons. And the dimension of newtons is, remember, by unit, kilogram meter per second squared. That is, we have m, l, then t power of minus 2. Now, this is what we have to equate with this. So we are having m, l, t minus 2 equals m, x, l, y, and t power of z. So from here we can see that x is 1, y is also 1, and then z is minus 2. That is the powers here. This is 1, 1, this is minus 2. So the correct option would be option B, where we have 1, 1, and minus 2. To determine the weight of an object, you could A. Use the beam balance, B. Use spring balance, C. Use none of these methods, and then D. Use any of these methods. Now, whenever you're in the physics lab and you are to take the measurement of the weight of a substance, the instrument that is often used is the spring balance. Now, get this. Beam balance is to mass, while spring balance is to weight. And you know that in the case of mass is a fundamental quantity while weight is a derived quantity. So that's one thing to also put behind your mind at that point. So note this: beam balance to mass, spring balance to weight. So if you are to determine the weight of an object, you would use a spring balance. So option B is the correct option. In this question, we see that a man walks 1 kilometer due east and then 1 kilometer due north. So we have to find his displacement. So let's solve. Now, following the Cartesian, we know that east is going to be towards the right. So from our start point here, the man is going to travel 1 kilometer here due east and then 1 kilometer due north, right? So at this point here, if this is the start point here, remember this is north, this will be west, this is south, and this is east. So his direction, which would be, remember this is also 1 kilometer, right? So his displacement is this, right? This is his displacement. And this is in the northeast direction. So we need this angle, right? And we also need this length here. So let's call this displacement S. To find this displacement S, we're going to apply the Pythagoras theorem. So where S squared equals 1 squared plus 1 squared. So S squared becomes 1 plus 1, that is 2. So S is square root of 2 in kilometers. Now to get this angle here, let's call that theta, right? We can apply tangent because tangent of theta will be opposite over adjacent, right? So if we apply tan theta equals opposite, which is 1, over adjacent, which is 1. So we see that tan theta is 1. So which implies that theta is tan inverse of 1. And that will give us 45 degrees. So if we have all of these and we know that this is northeast, therefore the correct answer will be square root of 2 kilometers north 45 degrees east. And when we look at all the options provided, the correct one is option C. A lorry travels 10 kilometers northwards, 4 kilometers eastwards, 6 kilometers southwards, and then 4 kilometers westwards to arrive at a point T. So we have to find the total displacement. Let's draw the vector diagram here. So let this be the start point. And since it's traveling north, we're going to go this way up. And we call this 10 kilometers. And then from where it stops here, it then moves 4 kilometers east. East is to the right. So I'm going to draw a line this way, right? So this will be 4 kilometers, right? Now, and then it comes southwards, 6 kilometers southwards. So we're making sure that it doesn't get up to this length, but at least more than half of it. So this will be 6 kilometers. And then 4 kilometers west. So west is to the left. So we're going to go this way to arrive at point T. Now, this is one of the differences between distance and displacement. If you were asked to find its total distance in this case, we would have done 10 plus 4 plus 6 plus 4. Okay? Because this is also 4 kilometers according to the question. But displacement is only going to consider start to finish. So meaning its total displacement is just this length here that we have here. Now if all of this is 10 and this is 6, that is its displacement S would therefore be 10 kilometers minus 6 kilometers. And we see that displacement here is 4 kilometers. Now the direction is from this start point towards the north. So it's going to be going north, 4 kilometers north. The correct option would therefore be option B. This question says, which of the following readings cannot be determined with a meter rule? Now, in an earlier question, we did mention that a meter rule is graduated in millimeters and centimeters. And the accuracy of a meter rule is in the tune of 0.05 centimeters. Right? So that you can measure up to 0.05 centimeters. Now, when we look at all of these options provided, we see that therefore it should be able to measure this, it should be able to measure this, it should be able to measure this, but it cannot measure 0.6 because it's not graduated in 0.01. It is 0.05 rather, not 0.01. So if it were 0.01, it would have worked for this. But here we have 0.56, which means there will be no measurement point for this 0.6. So it cannot measure this. So our correct option is A. Now with this, we've been able to solve quite a number of questions on measurements and units. So please do well to drop any other question you'd like us to solve on this topic in the comment section. I'm looking forward to yours, and trust me, we will definitely attend to every one of your comments. And as always, don't forget to like the videos, share them, and also subscribe to the channels. Thank you very much. I'll see you in the next video.